Hello, welcome to this lesson of linear algebra. Let's continue solving eigenvalues, and we'll now do a 3 by 3 matrix. You'll find that the process is the same, but sometimes the details are a little tougher. So the matrix here, 5, 4, 4, negative 7, negative 3, negative 1, 7, 4, 2. So that is our matrix. We want to find the eigenvalues of that matrix. So what you do is you take the determinant of the characteristic matrix. 5 minus lambda, 4, 4, negative 7, negative 3 minus lambda, negative 1, 7, 4, 2 minus lambda. So same thing, different day. You just take the minus lambdas on the diagonal and you're setting this determinant equal to 0. Now you can immediately see how much more work you have in front of you. Even though you can write it down easily, now you have to find the determinant of this 3 by 3, which is a lot more work than finding determinant of 2 by 2. So everything increases in complexity, but you know how to do this. Let's expand it about the first row. So what we'll have is 5 minus lambda. That's the first guy here. If we cross these out, this is what you're left with the submatrix. So it will be times the determinant of negative 3 minus lambda, negative 1, 4, and 2 minus lambda. That's the first term. Don't forget your negative sign because of that cofactor, and then you have a 4 times the determinant. And when you cross this with this, you're left with this, 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 and this. Negative 7, negative 1, 7, and 2 minus lambda. And then we have the third term, which is also a 4 times the determinant. If we cross this and this, we're left with this submatrix here, negative 7, negative 3 minus lambda, 7, and 4. Okay, so now we have something that's a little bit more complicated. So there's kind of good news and bad news here. The good news is it's easy to write down. The bad news is it's a little bit more work. But the good news, again, is that you know how to take the determinant of all of these 2 by 2 matrices. This is a crisscross, this is a crisscross, this is a crisscross. But you see how the complexity of it just jumped up a lot, even though none of it's hard, it's just you're more likely to make an error. So what I'm going to do is, if you were to do this crisscross, and if you were to do this crisscross and this crisscross, what you would have is 5 minus lambda. This polynomial that pops up as a result of this is lambda squared plus lambda minus 2. And then you're going to have minus 4. This one that pops up as a result of this is 7 lambda minus 7. And this guy that pops up as a result of that is 7 lambda minus 7. Rarely do I skip steps, but in this case I think it really is not very advantageous. I think you can understand that in order to get this determinant, you multiply this